Okay, hello all you cool cat and kittens. Okay, here we are, ready to rock and roll. Okay, so this is given 2 points on the coordinate plane, A and B. Find the distance between the 2 points using the distance formula. Okay, here's the distance formula. Okay, so at this point, you know, the E, again, we talked about yesterday, stands for the Euclidean distance. Okay, so I'm going to substitute these puppies in. We'll get 3 minus 1 squared plus 5 minus 2 squared. All right. Simplifying this, we'll see 2 squared plus 3 squared, excuse me, would give us 4 plus 9 equals the square root of 13. Okay, which is approximately, let's put this puppy in the calculator here. Okay, it would be 3.6 is the Euclidean distance. Okay. So again, this is a refresher from yesterday. Now, the new part, okay, is TaxiCab geometry. Okay, and this distance is defined as the sum of the vertical and horizontal distance of the 2 points. We might notice that this is the definition of distance is fairly natural. It is the minimum distance that a taxicab will need to travel to reach from point A to point B if all streets are only oriented or placed vertically and horizontally. For this reason, this metric is often referred to as the Manhattan metric. The Manhattan metric. Ooh, Lord. Okay. However, I guess we might call it the Uber geometry at this point, right? Or lift. So here's the formula. Okay. Notice the T here is for the taxi cab. Okay. And we are not squaring. There's no square roots. We are taking the absolute value of the differences and adding them together. All right. Now, I'm going to be collecting these notes at the end of class for a grade, so make sure you're writing this down. Okay. Example 1. Use the graph to the right, plot the following points. So you should be able to do this, I think, on your own, but we'll do this puppy real quick. Okay, you plot the points. That should be pretty self-explanatory. I think you guys can do that. All right. Now comes the real meat and bones of the lesson. Find the following distances to 2 decimal places. So you have the Euclidean distances, that's the d sub e, and the TaxiCab distances, which is d sub t. 2 different formulas here. Okay, d sub e. Okay, the 2 points would be the square root of x2 minus x1 squared plus y2 minus y1 squared. That's a really bad square root sign. Oh, okay. Okay, the taxicab distance, which is d sub t, is just going to be the absolute value. Here we go. Okay. So you're still subtracting there, but instead of squaring to the square root at the end, it's just the absolute value. All right. So now let's practice with this. Okay, I have to erase this because you know me, I need the space here. Ooh, let's fly. Okay, for sure. Okay, so let's find the Euclidean distance between A and B. Here's A, here's B. Take the square root. I'll have 1 minus 1 squared plus negative 2 minus 3 squared. Okay, this is what we did yesterday, so this is not new. 1 minus 1 gives us 0, and then negative 2 minus 3 is negative 5 squared. Okay, which should be 0 squared is 0, negative 5 squared is positive 25, which just equals 5. Okay. Then, continuing with this logic here, okay, what I'm going to do is I'm going to do the taxicab one next. Okay, and I'll do that one, and then let's do that one. No, we wanted to do it in green, but we'll do it in blue. Okay, so let's find the taxicab distance now from A to B. So what I can do there is the absolute value, still the same numbers of 1 minus 1, plus we have 3 minus negative 2, or negative 2 minus 3. Same result there. Okay. The square absolute value of 1 minus 1 is 0. This is not say LOL. Plus 3 minus negative 2, which should be 5. Okay, the absolute value of 0 is 0, and the absolute value of 5 is 5, for a total of 5. Okay, so here they turn out to be the exact same. Come on now, come on. Okay, that will not always happen now. So if you have any questions, if we're going too fast, pause the video and write this puppy down. Okay. Let's look at BC now. So let's find. Oh my goodness. Oh my goodness. Okay. So let's find the Euclidean distance here between B and C. Square root. Okay. And what you should do probably help if you actually look at the thing here. Okay. So look at the value. So BC now. So we're using B and C. We'll have -3 minus 1 squared plus -1 minus -2 squared. Okay. So -3 minus 1 is going to be -4 squared plus -1 minus -2. Okay, it becomes -1 plus 2, which is +1 squared. Okay, we can do this one in our heads. -4 squared is 16, plus 1 squared is 17. So we get the square root of 17, which is approximately 4.12. Alright. Now, we're going to find the taxicab distance between them. And here we have the taxicab distance between B and C. We still need those x and y values there. Why is it not going up? Come on, a little bugger. There we go. Here we have the absolute value, again, in B and C. So we'll have 1, well, we can do 1 minus -3 plus -2, oops, that should be an absolute value sign. -2 minus -1. Okay, 1 minus -3 is 4, plus -2 minus -1 will be the absolute value of -1. The absolute value of 4 is 4, plus the absolute value of -1, which is 1, gives us a taxicab distance of 5. Okay, and then let's do the last one now. So we need to find the Euclidean distance between C and D. Okay, and I have it in front of me, but it's also very highly on top of this paper here. It'll be the square root of 0 minus -3 squared plus 3 minus -1 squared. Okay, 0 minus -3 is going to be 3. And 3 minus -1 is going to be 4. 3 squared is going to be 9. Plus 4 squared is 16. This gives us the square root of 25, which would be 5. Okay. Oh, those 5s, my goodness. Now, okay, if I do the taxicab distance between these two here, this is D right here. Okay, the absolute value, okay, of what, -3 minus 0 plus the absolute value of -1 minus 3. Okay, which would give me the absolute value of -3 plus -1 minus 3 is going to be -4. So this gives me 3 plus 4, which is 7. Alright, so here we get a little bit of a bigger difference, right, than we were getting in the past. Okay. So here, if you know the Euclidean distance, so if we know d sub e between 2 points, say we know it's between A and B, does that tell us, so does d sub e basically, does that tell us the taxicab difference? Why or why not? No, it does not. No. Okay, the Euclidean distance, or d sub e of AB, okay, is allowed to go diagonally. Okay, which some of you may remember is the hypotenuse, okay, of a right triangle. Okay, TaxiCab can only go up and down. D sub t if AB can only go up or down. Okay, so no, it's not always going to be that like that. It's not always going to work. All right. Let's look at the next problem. One night on the 911 dispatcher, one night the 911 dispatcher for TaxiCab City receives a report of an accident at this point. So -1. So this is X. Okay. There are 2 police cars in the area. Car C, which is at 21. So this is car C, and car D, which is at -1, -1. So here's 2. Okay. Which car should be sent to the scene of the accident to arrive most quickly? So since the cars must drive on the streets, aka can't go diagonally and all that, we use taxicab geometry to measure the distances. Okay. So there's a couple ways you could do this. Okay. I'm going to show you the formula first, since we've been practicing with that. So the taxicab distance between X and C. So let's find it between X and car C. Well, X, which is the accident, and C, which is the car. Okay, so these are my points here. So if I do X and C, I'll have -1 minus 2 plus the absolute value of 4 minus 1. Okay, which will give me then -1 minus 2 is -3 plus 4 minus 1, which is also 3. So -3 becomes +3 plus 3 gives me 6. So the distance that the car C is from the accident is 6 units. Let's find the distance from the accident to car D now. Okay, again, same setup here. Okay, we have -1 minus -1 plus 4 minus -1. Okay. Well, -1 minus -1 is actually these two negatives make a positive, so this will give us 0. Plus 4 minus -1 will give us 5. So this one here is going to be 5 units away. So who's closer? Car D is closer. Not car B. Car D is closer. So that's who should be sent. Now, there is another way to do this, and let me show you. Okay, because if some of you ask, why are we graphing if we're not going to use the graph? But we will use the graph. Okay, you can. Now, sometimes I'll force your hand and won't let you use a graph. I want you to use these formulas because I want you to practice. Okay? But if you look at the graph here, okay, how far is X from D? So if you go 1, 2, 3, 4, 5, this is simply just 5 units. And there's another thing as we got right here, 5. And if you look here, you have 1, 2, 3, so this is 3 units. 4, 5, 6, this is another 3 units, right? So if you add them together, don't you get 6, which is what we got right there. So there are 2 ways to get the same problem, the same answer. All right. Example 3. Using taxicab geometry, consider these 2 points. Okay, so is the point -2, -3, -2, -3. So we'll call this point C. I'll call this point C. Closer to A or B. So let's use the formula for this one. And then the second one, we will use the graph. Okay. So if I find the distance between C and A, that would be the absolute value. The absolute value of -2 minus -3 plus the absolute value of -3 minus 2. Okay. So using this math here, okay, -2 minus -3 would be +1, plus -3 minus 2 is going to be -5. Okay, so then the absolute value of 1 is 1, absolute value of -5 is 5, so this gives us 6 is our answer. Okay, and let's find the taxicab distance between C and B. Okay, so doing that, we have the absolute value here of -2 minus 3, plus the absolute value of -3 minus 0. So -2 minus -3 is going to be -5, plus -3 minus 0 is going to be -3. So the absolute value of -5 plus -3 is going to be 8, because we're going to take the absolute value of that. So it's closer. So for this one, car A is closer. So this is the second time we've been doing a problem like this. Now, I just did one in the last example, and now this example. So you can bet your bottom dollar you see this on the quiz. Okay. And then it's the point 1, -2, which we'll call D. So 1, -2, plot that puppy. Is that closer to A or B? So now what I'll do is, for the sake of time purposes, and so you can see other alternatives, let's just, figure out using the graph. So from D to B, we have 2 here and 2 here. Right? So the distance from D to B would be 2 plus 2, which equals 4. What kind of 4 that is. Okay, and the distance from D to A is we go up 1, 2, 3, 4. So up 4. 1, 2, 3, 4 over 4. So the distance then, taxicab distance from D to A would be 4 plus 4, which is 8. Again, I'm not really sure what kind of 8 that is. Okay. 8. Okay. Now, again, in my answer key, which I'll post online later, tomorrow or something, okay, you'll see that I did them both ways for each problem. Okay? For the sake of the video and time purposes, I'm not going to have us do that, but you need to get familiar with both methods in A and B. So here, car B is closer. Okay? So now let's look at example 4. Okay? Example 4, plot A, which is 0, 0 on the graph. Okay, here's A, and plot B, which is 6, 0. So that's actually off the graph a little bit, but that's okay. Find and draw the set of points equidistant from A and B. So this is just equal distances. So the points that are the same distance away from each of them. So in order to do that, we need to figure out how far they are away from each other in the first place. So I find the taxicab distance here between A and B will be 0 minus 6 plus 0 minus 0. 0 minus 6 would be -6 plus the absolute value of 0, which gives us 6 plus 0, which is just 6. So we know that A and B are 6 units away from each other. 6 units. Right? I mean, that was clear off the graph, but it won't always be that clear. So, but we need to find the points that are equal distances. So if they're equal distances, that means they're 3 units away. Alright? So if I go to point A, I can go 3 distances. 1, 2, 3. So point right here, right? I can go up 1 and over 2. I'm sorry. What the world? Okay. So again, I can find all points that are 3 units away, right? So basically any point there that lies on this line right here, because they're all going to be the same distances away from each of them. And you can connect them with a line. As we look at it, okay, say I pick, come on, switch over, this point right here. That point will be 1, 2, 3, 4, 5, 6 units from A, and that point will also be 1, 2, 3, 4, 5, 6 units from B. So it's the same amount of points away. Okay. That was kind of an easy one. So let's, kick into gear now. Okay, example 4, plot the point 0, 0, which is A again. And then plot the point 4, 2, B. Okay, and find the center points equidistant from A. Now, if you look at this here, okay, you'll notice that, it's not as easy as the last one because you're not on the same level. So let's find the TaxiCab distance between A and B real quick. That would be 0 minus 4 plus 0 minus 2. So 0 minus 4 is negative 4 and negative 2. Which gives us 4 plus 2, which happens to be 6 again. Okay. Now here's where this problem is a little bit different than the last one. Okay, as we know that there's 6, so all the points equidistant then will be 3 units, right? So I can go up 1, go over 2, that's still 3 units, right? If I go up 2 over 1, that's 3 units. I can go over to the right 3 units. 1, 2, 3. Okay, and keep doing this. Go up 3. 1, 2, 3. Right? Now, if you look at it here, you might think, oh, it's going to be a horizontal line. It's actually not. Right? Because if you look at this here, I keep saying that, my goodness. I can go, good. That's not right. You're so all messed up. Oopsies, oopsies. Okay, so you need to have the points that are equidistant. So I'm going to change my color here. So if I go up 1, 2, 3, 4, this is 4 units, right, from A. And that's also going to be 1, 2, 3, 4 units from B. Okay, because if I go up another one, there'll be 5 and 6. Okay, and then if I go 1, 2, 3, 4, this would be 4 units. 1, 2, 3, 4 units. And you can keep doing that over and over and over again. Okay? Wasn't that erased? Let's go, come on, buddy. You can do it. Okay. So if you draw the line here, I'll draw the line in red. All those points are equal distances from A and from B. Okay? That was fun. Okay, and the last question, calculate the following for A, B, and C and D. Plot the points. So A is 0, 0. B is 5, 0. C is 2, 3. And D is 3, 4. Oops. So you should be plotting these buggers. Oh my goodness, what just happened? Oh my goodness, what is going on? Okay, some witchcraft happened here. Okay, calculate the distance between A and B, the Euclidean distance for both of these. These are Euclidean now, so that's an important part to recognize. Okay, so the Euclidean distance between A and B. Okay, do the square root. Now remember, for the Euclidean distance between any 2 points, okay, we'll call x comma y. Doesn't, let's call it a b. B. Remember, that's the formula we used yesterday. Okay. So then we'll have what? We'll have 5 minus 0 squared plus 0 minus 0 squared, which is a pretty fairly easy one to do. 5 minus 0 is just going to be 5 squared, and 0 minus 0 is 0, so 5 squared is 25. You hit the square root of 25 and you get 5. Okay. So let's find the Euclidean distance here, okay, of what? AC. So then we'll have 2 minus 0 squared plus 3 minus 0 squared. Okay, 2 minus 0 is going to be 2 squared plus 3 minus 0 is 3 squared Okay, which gives us 2 squared is 4, 3 squared is 9, so it gives us the square root of 13. Okay. And then C, calculate the taxicab distance between A and B and the Euclidean distance between A and C. Okay. I think that's a typo there. That should be a typo. This should be the taxicab distance. So this, let me just cross this puppy up. This should say the taxicab distance between A and C. That's what it should say. Okay. Oopsies. So let's find the taxicab distance here between A and B. Absolute value of 0 minus 5 plus the absolute value of what? 0 minus 0. This gives us the absolute value of negative 5 plus the absolute value of 0, which I'm not going to write, which is just 5. So these match up, don't they? Good job, they match up. Yay! Everybody, we win, yay! Okay, and then let's find the taxicab distance between A and C. Okay, so we have the absolute value of 2 minus 0 plus the absolute value of 3 minus 0. 2 minus 0 is going to be 2 plus 3 minus 0 is just 3, which gives us 5. So these, the issue, I guess, be right here and right here. They do not equal each other. So does the Euclidean distance equal the... So if the two Euclidean distances are equal, does that imply that the two taxicab distances will be equal? The Euclidean of PQ equal the Euclidean of RS, imply that the taxicab of PQ equal the taxicab of RS. It does not. Okay, no, it does not. Okay. Was that messed up here? I don't know. The question's kind of confusing. And I made this. Oh my. Okay. But I think this notation here, this blue one kind of threw me off there. So no, it does not always. It does not always imply. Sometimes it will, but not always. So don't bank on it. Alright? So make sure you have your name on this and hand this puppy in. Alright?